All right, so let's talk a little bit about lunar proving ground facility needs. Let's see, work, maybe. There we go. All right, so we want to go back to the moon, and in the end, we would like to do so in a sustainable manner. Okay, clicked too many times apparently. So we want to do lots of different things in the future there. All right, we want to create power, mining, processing, manufacturing, create a sort of self-sustaining, base outpost first, grow maybe perhaps into a settlement into the future. All of that requires large mass, large power requirements, all these kinds of things. And so how do we get started with that? Now, the space exploration is growing very rapidly. There's new capabilities coming online that we haven't ever had, really. Specifically in the commercial sector as well. Of course, NASA is benefiting from that, but SpaceX do a lot on their own as well, which allows commercial opportunities, again, that didn't exist before. Large launches of payloads to low Earth orbit, and then from then on to other places in the solar system, not just the moon, but that's where we start. All right, so what kind of scale do we need to do operations? What kind of scales are envisioned? And so this comes right from the NASA exercise, from the different thrusts, the LIV engineering, excavation, construction, NISRU. You can see some different scales on there, right? So we're talking hundreds of metric tons, thousands of metric tons of excavation. And so not exactly your science rover that picks up a small sample, right? So we're talking a very different scale of things that we need to do, different operations. Now, I've done a study a while back for Mars, but this applies to the moon in the same way. If you want to gather a certain amount of regolith, then you need to have some vehicles to do that. So what kind of size vehicles do you need? And then how far do they have to drive? So this is part of an exercise that was done for that. And so depending on what kind of resource, again, this is on Mars, things like gypsum or regular regolith, for water extraction do you need? And so in this particular case, we found that, if you want to go 100 meters away, you need to have a certain amount of regolith. You needed to make 25,000 trips. A total of about 5,000 kilometers traveling, right? So that's very different from the furthest that any rover has traveled on another planetary surface, right? So you see that on the right. It's a little bit outdated now, but somewhere around 50 kilometers. So that's 2 orders of magnitudes further. Plus, you have to haul 2,000 metric tons of material while you do this. So again, not exactly your science robot, right? This is a very different kind of machine that we're talking about. So how do you design for these things? How do you build for such things? You need to have a design shift here. You need to design different things. And nobody really has designed these kinds of vehicles. We've done it for Earth, like we heard earlier from Caterpillar and other companies. But you need to be able to do different things. You have to dig in the dirt literally all the time. And you can, of course, avoid the dust partially by designing properly for it, but you can't avoid it in the sense that you're constantly interacting with it. Your job is to carry it. So you can't very carefully walk around because you need to dig it, you need to handle it. That's the reason why we're doing things like that. So a very different design paradigm than what we're used to. So how do you test these kinds of vehicles right now? Go to some examples, look at field testing, and then needing the larger scale. So I'm talking a little bit from my own experience here. So my own facility, we do indoor testing of these machines. We test small vehicles. We're talking, maybe a meter class vehicles here. We can test things like slopes. How can we drive on these? We can do dusty thermal vacuum testing at a small scale. But if you're talking about icy regolith, for instance, handling icy regolith is not a simple thing when you are in atmospheric conditions, because you need to freeze it, you need to put the water in there, then you need to put it in your vacuum chamber. Then you're done testing, but now you have wet regolith. You don't want to ever put wet regolith in your vacuum chamber, by the way. It took my students 4 hours to clean it up after the last time they did. Dressed up, of course, all in PPE. But anyway, how do you deal with this in large quantities? So we have an actual drying container where we dry the regolith before we then refreeze it and then mix a certain amount of water ice in it. So handling that on a daily basis, which we do to about the 1 metric ton of regolith simulant, can be done. But again, that's still a very small scale, much smaller than we need for these large scale operations. We do excavation testing. We do field testing as well. So, small vehicles, again, you can drive those outdoors. If you want to drive long distances, there's no vacuum chamber that I can afford anyway, where I could test that. So we go outside. We have some unique facilities there where we can do some things like that. But it's not exactly the moon. So the question is, how relevant or how accurate is the results from such tests? Can they be applied to the moon, yes or no? So we have a lot of capabilities to do indoor lab scale testing, but only to about a meter class size vehicles. And is that enough? So what else do we do? Well, we can do material testing. One of the main concerns that was brought up is maintenance and wear. So one of the things we've developed is an in-house test where we can do material testing, a modified ASTM test, but now done in vacuum under cryogenic conditions, just to test material wear under lunar conditions, as opposed to on Earth. We also look at material transport. We need to handle this material the whole time. But if I do a 5-minute test, is that representative for going 5 years on the lunar surface without maintenance? Right, so how do I qualify this? So the job here that we're trying to do is put it in these environments and test it until it breaks. Learn, this is redesign it and fix it. And that's how you improve, because you can't analyze this stuff. We simply don't have the data to do a good design or a good analysis. So is the tests that you do in the field, are they relevant, yes or no? Again, this is something we have here. It exists in other places too. We're far up north, further north actually on 50% of the Canadians, but we're still in the US, sticking out in Lake Superior. Here's Michigan in the picture there. Anyway, so we have some mining relics, old mining relics. There was a lot of copper mined in this site back in the 1860s to the 1960s. And a lot of leftover crushed basalt exists from those mining days. And that's actually what we use to do some of our testing in. And here you can sort of see what that looks like, right? So these stamp sands were crushed to get the copper out, and the crushed basalt was basically just dumped. And you can see here along the coastline, that sand is all crushed basalt. There's hundreds, if not thousands of acres of this stuff. It's pretty decent material to simulate the moon with. But we also get 300 inches of snow where we are, so it's great for frozen ice testing. A little more ice than you want. I shovel more ice off my driveway than we need to launch a rocket from the moon every day. But anyway, it's a pretty cool thing to test. So we test things like ground penetrating radar. Can we detect that ice block that's buried there, yes or no? Again, we can do lots of these kinds of operational tests. We can figure out what the data looks like, but is this really representative? Is this good enough to prove that we can do this on the moon as well? It gives us and my students a lot of experience in doing these kinds of things, but I still don't think it's really good enough for real lunar applications. And so what's sort of the next step? Well, proving grounds on Earth exist in several different ways. We have one that happens to be at Michigan Tech because we get so much snow. They have a winter test facility. It's also available in the summer, of course. But we test literally any vehicle you can think of that's commercially produced under winter conditions here. It's 900 acres of snow fun. Here you can see some satellite pictures of what that looks like. 900 acres where you have a lot of different kinds of test facilities. So this is a proving ground that in the winter, there are literally 100 different tests going on simultaneously by different car manufacturers and all things like that. And so these circles, right, for high-speed testing, for how does the vehicle behave? We make different obstacle tests. How do your suspensions hold up when you go over these giant concrete barriers, things like that. Make slush conditions, icy conditions, anything you want. But the nice thing is in the summer, it's used only a little bit, and so we can test our robots there also. So it's a pretty nice facility in that sense. Now, what other kind of things exist around the world? Oh, one more thing. We are using this also to do some lunar tests where we're actually creating a trench filled with lunar simulants. Simulant is another big question for proving grounds because that stamp sand I was talking about, this nice crushed basalt, but it's pretty coarse. All the fines have been blown away and washed away. So how do you make sure that your behavior, your wear and tear is similar? You need lunar simulants, but it's very expensive. Exolit, I think, is $35 a kilogram. Well, I needed to buy 25,000 kilograms of it. I don't have that in the budget. So we make our own, which is similar, for only $3 a kilogram. Still, that's about $75,000 they got to pay for just dirt, essentially. But it is at least lunar simulant dirt. Anyway, so this gives us an opportunity to go out there and test, build the trench, and test under more lunar conditions. Since it is cold in the winter, we can do icy frozen testing there as well, even though it is actually in lunar simulants. The key is to keep it dry when we're outside. That's a really tricky part when you're outside. All right, what other facilities exist on Earth? And could we model our maybe future lunar proving ground in a similar manner? Well, I was looking for proving grounds. So I actually found one here from a long time ago for the Apollo test facilities. In this case, I think it was Northrop Grumman. But anyway, they were starting with one of their first lunar proving grounds to test the lunar rover vehicle. So pretty interesting system there. This was 1965. Then on Earth, a good example, we've heard from Caterpillar already. And so here's an example of one of several facilities that Caterpillar has. This is a small 6,500 acre test facility they have. But again, they also operate very small vehicles, as you can see on the top right there. There's a whole family of them, very large vehicles. So you need large proving grounds. In the center, sort of, you can see a underground proving ground, actually, where they simulate the tunnels by the constraints of the walls over there. But also, Caterpillar has indoor proving grounds, for instance. So they have a variety of different proving grounds, not only to demonstrate, but also train the operators, and of course, test the vehicles during development. So lots of different uses for different facilities. These are large facilities. The equipment really needs to be put through their paces and break before you would sell it to the customers, basically. Now, Europe is also building some new test facilities specifically for lunar applications. You can see the one in Luxembourg down on the right, which is currently in planning. You can see some examples of the European Rover Challenge, which was a proving ground just made for that competition and then torn down. It's not actually lunar dust. This is more like a sandy material, so nobody has to wear PPE. Question again, is that relevant? Is that appropriate? Maybe for operations, but not for wear and tear. Also, short duration testing. Then ESA, European Space Agency, has several small facilities that they have for Moon and then sometimes Mars Yard type things. But again, very small. If I have to drive 5,000 kilometers, I didn't do the math, but that's a lot of circles on that really small of a patch of ground. So not the right size for those kinds of tests that we need to do. All right, so what else is there? Mission Control, I think we have Kaizad here from Mission Control, right? So you guys have a pretty nice facility up in Canada, about 10 meters, 10 by 20 meters or something like that. Pretty good size, but again, 5,000 kilometers, very difficult to do in such a small facility. It's really nice, great for testing, but again, not the right scale for what we're going to need down the line. So another company, Canadensis in Canada, they drove 600 kilometers with their drivetrain. But the way they did that is they have stationary drivetrain, and then they have a turntable that basically rotates the lunar simulant underneath the wheel. So it can test a component, but again, not the full system, and it doesn't do any excavation operations. That's just the drivetrain. So there's some ways you can get some testing in at a small scale. All right, what else is there? Australia, they are actually building quite a few small test facilities. The biggest one is somewhere around 20 by 10 meters. Again, great for small rovers. They're very new still. They just have the Australian Space Agency for about 5 years or so. So pretty cool that they're really into this stuff. They tie into the mining industry really well too. All right, what else do we have? Then of course there's NASA. NASA and JPL and other places, they have lots of test facilities. However, they're very expensive for me as an outsider to go test for things like that. They have some larger scale facilities as well, and they can do lunar and Mars environment testing. But if I wanted to book it, maybe I have to wait 3 years because they have a program in there right now. So availability is another issue for the few facilities that do exist. Then why do we need big facilities? And what would it look like? Well, there's a lot of questions here. I don't think the community has really figured out what is really needed. And so I tried to get some important items on here that I think are relevant for developing a lunar proving ground facility that can test at the scale and duration of the things we're going to need to do. So really, we need to develop requirements, right? So we're talking about space stuff, and so we need requirements, right? The question in my mind really is, what's the relevant environment for this case, right? If you look at the TRL levels, relevant environment testing, but it's not very well defined when we talk about dealing with lunar simulant and vehicles that interact with that. And so what is relevant? Is the stamp sensor we're talking about, is that relevant enough? Is that good enough? Or does it really have to be tested in simulant, yes or no? Does it need to be cold? Does it need to be under vacuum conditions? All these kinds of things are really important questions. Things like gravity offloading, right? If you develop a facility, does it really need the ability to do gravity offloading or not? Important questions. And what kind of tests do we need to be doing there? Or can it be done in the lab at a smaller scale? How big of a test do we want to do? All right, so I do think there is a need for a large facility, hundreds, thousands of acres perhaps, where we can test really big things. That could probably be outside. Should there be an internal component of that as well? Well, again, some questions that I've come up with here that I think need answering before we can really start developing this. One of the questions in my mind is, like, how is this going to be organized? Should this be an individual entity that owns and operates this? Or should it be more of a sort of consortium, or maybe a national lab type setup where everybody could go and use it, for instance, things like that. At the same time, do you want to build it from scratch? Or, maybe you want to leverage existing facilities such as the QNR Research Center we have up there. They have the expertise, they have, operators to move dirt around. We do that all the time. So maybe that's a good place to do it. There's other facilities like this around the nation, I know, but, do you want to do IC testing? Maybe this is the place to go. I don't know. Lots of questions here. And so it's great that we're starting to have this conversation. I think there's still a lot of work ahead to really narrow this down. So I tried to get some idea of what the needs might be for a facility like that. And so I think that's all I have for you today. Thank you.